What if Earth were sucked into a black hole? The silent threat lurking in space. Could a black hole devour us all one day? It sounds like the kind of question you ask at 3 a.m., right before deciding space is terrifying and going back to cat videos. But here's the unsettling truth. Black holes are real, they're everywhere, and they're incredibly hungry. There are millions of them drifting through our galaxy alone, silently warping space and time. Most of them are far away, minding their own cosmic business. But what if one didn't? What if a black hole wandered just a little too close to Earth? This is what if. And here's what would really happen if Earth were sucked into a black hole. What exactly is a black hole? Despite the name, a black hole isn't a hole at all. It's an object so dense, so massive, that it bends space itself into submission. Most black holes form when enormous stars, at least 10 to 20 times more massive than our sun, run out of fuel. Gravity takes over. The star collapses inward, crushing itself into a point of unimaginable density. What's left behind is a stellar black hole, roughly 16 kilometers across, more massive than our sun, invisible to the naked eye, and that's just the small kind. The big boss, supermassive black holes. Then there are the monsters. Supermassive black holes sit at the centers of galaxies. They can be as wide as our entire solar system, and they can weigh millions or even billions of suns. There's one right now at the center of the Milky Way. Its name? Sagittarius A. Relax. It's about 26,000 light-years away, and it's not coming for us anytime soon. Probably. How close is too close? Here's where things get uncomfortable. A black hole doesn't need to be large to destroy Earth. It just needs to be close enough. In theory, a black hole the size of a pinhead could obliterate our planet if it passed nearby, because its mass would still be enormous. The real danger zone is something called the event horizon. Think of it as the black hole's point of no return. Once you cross it, escape becomes impossible. You'd need to move faster than light. And physics basically gives up trying to explain things. Good luck with that. The first signs of doom. If a black hole started approaching Earth, we wouldn't notice immediately. No dramatic sky changes, no cosmic alarm bells. At first, life goes on as normal, but deep beneath our feet, something feels wrong. The side of Earth facing the black hole begins to stretch toward it. Not visually, not yet. Gravitational forces start pulling unevenly across the planet. This is called tidal force, and it's about to ruin everyone's day. Earth begins to tear itself apart. As the black hole draws closer, Earth's atmosphere would be the first thing to go. The upper layers would be vacuumed into space, spiraling toward the black hole like water down a drain. Then the surface follows. Entire chunks of crust rip away, oceans lift into the sky, mountains crack. Earth doesn't explode, it unravels. Tidal heating, the planet starts cooking. Now let's say, somehow, Earth doesn't fall straight in. Instead, it gets caught in orbit around the black hole. Sounds promising. It's not. The uneven gravitational pull squeezes and stretches the planet over and over again. This creates intense, internal friction. The result? Tidal heating. Earth's core begins to overheat catastrophically. Volcanoes erupt everywhere. Earthquakes shake the entire globe. Tsunamis erase coastlines. It's the ultimate natural disaster combo. The trifecta of doom. Spaghettification, and no, it's not delicious. Eventually, Earth gets closer, much closer. Now comes the moment space physicists love to joke about and everyone else fears, spaghettification. As Earth approaches the black hole, the side closer to it is pulled harder. The far side lags behind. The planet stretches like taffy. Imagine Earth turning into a long, thin cosmic noodle, not in a tasty, cheesy way, in a horrifying, end-of-everything way. What if you face the black hole? Let's zoom in. You decide to face the black hole head-on, superhero style. Your arms are closer to the black hole than your legs. That means gravity pulls them harder. Your body stretches vertically. Your atoms begin to separate. You're pulled thinner and thinner. Unless your superpower is elasticity, you're done. Does size matter? Yes. Very much. For a stellar black hole, spaghettification happens before you even reach the event horizon. For a supermassive black hole, something stranger happens. You could cross the event horizon intact, at least at first, but don't celebrate yet. The final breakdown. No matter the size, everything that enters a black hole meets the same fate eventually. Planets, stars, people, all are torn down into strings of individual atoms, and that includes Earth. Part 2. The death of the solar system. What happens to the Sun? If Earth is in trouble, you can bet the rest of the solar system isn't doing great either. A black hole close enough to affect Earth wouldn't come quietly. Its gravity would start pulling on everything bound to the Sun. Planets wobble, orbits destabilize. The elegant cosmic clockwork we call the solar system starts to fall apart. The Sun itself could be affected in two terrifying ways. 1. Dragged toward the black hole. 2. Forced into a chaotic orbit around it. Either way, this is bad news for us. Planetary chaos begins. Mercury and Venus would be the first to go. Their orbits are tight and fast, which makes them incredibly sensitive to gravitational disruption. One strong pull from the black hole, and they're gone, either flung into deep space or swallowed whole. Mars follows soon after. Jupiter, Saturn, Uranus, and Neptune might resist longer thanks to their massive size. But even giants aren't immune to a cosmic bully with infinite appetite. Eventually, nothing remains stable. The asteroid belt turns against us now for the insult on top of injury. Between Mars and Jupiter lies the asteroid belt, home to more than 500,000 known objects. When gravity goes wild, those asteroids don't politely stay put, they get redirected toward us. Hundreds of asteroids larger than 100 kilometers could be sent crashing inward. One of those would end life on Earth instantly. Several, you wouldn't even notice spaghettification before it was over. Radiation. The silent killer. As matter falls toward a black hole, it doesn't just disappear. It forms something called an accretion disk, a swirling ring of superheated material spiraling toward destruction. This disk emits X-rays, gamma radiation, extreme electromagnetic energy. Even from a distance, that radiation would sterilize Earth. Oceans boil, DNA breaks down, life ends long before the planet does. Could Earth orbit the Sun and a black hole? Believe it or not, in theory, yes. Astronomers have discovered rare circumbinary planets, worlds that orbit two stars at once. So could Earth orbit the Sun and a black hole? Technically possible. Practically survivable? Absolutely not. Why dual orbits would kill us? The gravitational tug-of-war would stretch Earth continuously. Day-night cycles become erratic, seasons vanish, tidal forces skyrocket, the planet would be heated from the inside out, oceans evaporate, crust fractures, atmosphere escapes, Earth becomes a molten, uninhabitable rock. What if we tried to escape? Let's get desperate. Humanity sees this coming decades in advance. Could we build massive space habitats, reinforced generation ships, a planetary shield? Even then, radiation levels would fry electronics, gravity distortions would rip structures apart, navigation becomes impossible, there is no outrunning a black hole. What if we went into the black hole? Okay, last resort, humanity builds a hyper-reinforced spacecraft and aims straight for the black hole. Maybe physics changes, maybe we survive, maybe we exit somewhere else. What happens past the event horizon? We don't know. Beyond the event horizon. Once inside, the rules of the universe break. Time may slow to a crawl. Space may fold in on itself. Cause and effect might swap places. Some theories suggest parallel universes, wormholes, entirely new dimensions. Others suggest instant annihilation. Unfortunately, no information ever escapes a black hole, which means, if someone made it out, we'd never know. The uncomfortable possibility. Here's a thought that keeps physicists awake at night. What if our universe is already inside a black hole? What if the Big Bang was the other side of one? We can't disprove it, and that might be the scariest part. The final fall and the last thing you'd ever see. What would a distant observer see? Here's where things get truly strange. Imagine an astronaut far away, safely watching Earth fall toward the black hole. From their perspective, something odd happens. Earth never quite seems to fall in, as our planet approaches the event horizon. It appears to slow down. It becomes dimmer, redder, more stretched. Time itself appears to freeze. Earth looks like it's stuck forever at the edge of the black hole, fading into darkness. From the outside, Earth never crosses the event horizon. But from Earth's perspective, completely different story. For anyone on Earth, time feels normal. There's no freezing, no slow motion. You cross the event horizon in seconds. No alarms, no warnings, no dramatic flash, just a quiet, irreversible step into the unknown. The point of no return. Once Earth crosses the event horizon, there is no future where it comes back. The sun disappears, the stars vanish, the universe collapses into a single direction, down. Gravity becomes unstoppable, space becomes one way, time becomes meaningless. There's no up, no out, only inward. The final breakdown of Earth. As Earth is stretched thinner and thinner, molecules separate, atoms break apart, subatomic particles unravel mountains, oceans, cities, history, all reduced to streams of energy. Earth doesn't explode, it forgets itself. Does anything survive, in any recognizable form? No. Even information, memories of Earth, of humanity, become scrambled. Stephen Hawking once suggested that information might not be lost forever, only transformed. But if that's true, then whatever remains of us exists as quantum whispers on the edge of reality. Not alive, not dead, just scattered. Could this ever really happen? Here's the good news. Black holes don't just wander around randomly. The nearest dangerous ones are thousands of light years away. Nothing is on a collision course with Earth. For now. The universe is violent, but it's also patient. The bigger question. Black holes remind us of something uncomfortable. No matter how advanced we become, no matter how far we travel, no matter how much we understand, the universe does not care. It doesn't hate us. It doesn't notice us. And that might be the most terrifying thought of all. If Earth were ever pulled into a black hole, there would be no heroes, no escape ships, no last-minute solutions, just physics, gravity, and the end of a story 4.5 billion years in the making. This is If World. If you enjoy exploring the most extreme what-if scenarios, from black holes and alien worlds to the far future of humanity, subscribe to the channel, because some questions don't have comforting answers, and some stories end at the edge of space and time.